Hello everyone, good day from here. My name is Michael, and today I'm going to be talking about portfolio theory. Portfolio theory. What is a portfolio? A portfolio is a collection of security. It's a collection of security, or it's a collection of different investments. That is what we call a portfolio. And what is a security? Security, another name for security is investment. Investment in stock, investment in cash and cash equivalents, investment in financial instruments. These are what we call securities. Okay, now when we talk about portfolio theory, an investor will want to hold securities or different securities. So, and in holding security, there's what we call, and remember I said portfolio is a collection of different securities. So in holding these securities, we need to balance risk and return. Risk and return. Portfolio is a collection of securities, and securities are so a portfolio is a collection of securities. That's one. Two, securities are different investments in, e.g., financial instruments, cash and cash equivalent, stock, and so on and so forth. So, when you are holding an investment, there is what we call risk and return. Risk, every investment has risk, but it is assumed that the government bonds has a risk-free rate. Risk-free rate. Note that it has a risk-free rate only when it is dominated in the currency of the country, the home currency. It is risk-free rate. For instance, you borrow, a government borrowed money from you. It is expected that the government will have to pay that money because government is not running anywhere. They will have to stay, but it must be dominated in the country's currency. Because if it is dominated in another currency, it may be subjected to currency movements, inflation, interest rates movements, and currency risk. So when you invest in a company, first of all, to the investment company, it is cost of capital. When you invest to a company, it is called, to the investment company, it is cost of capital because they are paying interest they are paying you interest on investments. But to you, that is the investor, it is called return on investment. It is called return. To the investor, it is called return on investment. To the investment company, it is called cost of capital. To the company, it's a cost because they are going to be paying you interest. Why? To you, the investor, it is return on investment. Okay, now when we talk about whether it's a cost of capital or return on investment, there is the risk, because every investment, apart from the government bonds, that is assumed to be risk-free. Every other investment has risk embedded in it. So risk versus return. Risk versus return. Now, the higher the risk, the higher the risk, the higher the return. That's what this is. It is expected. The higher the risk, the higher the return. The higher the return, the higher the risk. But the lower the risk, the lower the return. So they work pari passu. When the risk is high, it is expected that the return will be high to correspond with the high risk. Investors will not want to invest in a risky business or a risky investment that has low return. For instance, we have an investment that has the rate of risk is 20%, return is let's say 50% return. Investment 1, investment 2, we have risk of say 30%, and if the return is 55%. If I'm to choose which to invest in, I will go for, even though the return is 55 for investment 2, I want to go for investment 1 because the return is 50. So if you look at the margin here is 10, but the margin here for the return is 5. So I will not want to add 10% of risk to have just 5%. If I am risk averse, I will go for investment 1. Investment 1 has a risk of 20% and return of 50. Investment 2 has 30% and has a return of 55. The margin, this is 10, this is 5. So the return has declined, is higher than the risk. So that's it. So there are different investors. There are investors that are risk neutral. There are investors that are risk averse. There are investors that are risk takers, risk lovers. So depending on investment type, but a rational investment, and for a rational investor, we want to go for a lower risk with considerable return. They are okay with it. If the risk is high, then the return should be high to correspond with the risk, and to compensate the investor for the risk. So now, you can take notes, or you can pause the video, then take notes. I have to clean. Now, in talking about this risk versus return, the graph is something like this. Let's say this is return, this is risk. Here we have risk one, risk two, risk three. The higher the risk, the higher the return. So when the risk is when the return is at level 1, the risk is 1. Return is 2, it's going higher, the risk is 2. Risk is like that. So as the risk is rising, the return is expected to also rise to correspond with the risk. Okay. So having said that, the risk is measured in what we call statistical instrument. We use to, or in statistics, we use to measure the risk, we use standard deviation. Measurement of risk, we use standard deviation. And the standard deviation is, we use this as the symbol for standard deviation. This is like in English, in phonics, this is like Z diphthong or something, or the other one, can't remember the name. But this is what we use, symbol for standard deviation. And when you square the standard deviation, we have the variance. The variance for the standard deviation. So when you are given a question and you are given a raw data like series of figures and their corresponding probabilities, you have to get the standard deviation. I'll show you the formula you use and how to work it out. But in some cases, they will give you the standard deviation for you to use and get other things. So that is that. Okay. So let's assume that we have a question here that says, let's practicalize something. Let's say we have probability in percentage, let's say 30, 40, 30. Note that these probabilities they are in percentage already. They are in percentage. Then we have internal rate of return or return, also in percentage, 27, 27, 18, 5. This is for security A. Then return for security B, we have 35, 15, 20. Now, if you are told to find, sorry about that, you are told to find the standard deviation of this is a raw data. Excuse me. So, if you are told to find the standard deviation of this security A, investment B. Now, the standard deviation shows, like I said, the standard deviation shows is a measurement of the risk involved in both securities, both investments. So, we want to see the possible deviation from the expected. What's risk? Risk is the probability that the actual will be different from the expected, or the expected will be different from the actual. For instance, you are expecting a return of 35%. There is the probability that we will not get that 25%. Either will be lower than or will be higher than. So it is a risk that there will be the probability that there will be a deviation from the expected. So this is a raw data. We have different securities at different probability level. So here's how you go about it. If you have been asked to find the deviation, standard deviation of these securities. Let's start with security A, or investment A. Security A. We have now you can, either way you want to do it, you can convert the percentage into decimal points, into a fraction, so that it will be easier for you to calculate. Now, there is the expected value. This EV is expected value. Expected value is calculated by multiplying the probability with the return. Multiplying the return with the probability, or multiplying the probability with the return. That is expected value. Anytime you see they ask you to look for expected value in a raw data given like this, it's just talking about using the probability, multiplying the probability with the return. It can be NPV, net present value, it can be other figures can be given. So you just need to multiply the probability figure with the what is given, the value that is given to get the expected value. So for you to get the expected value, you will have to multiply the probability with the return. So let's do that here with my calculator. So we have 8.1 7.2 1.5. Okay. So when you add this up, 8.1 plus 8.1 plus 7.2 plus 1.5, I have 16.8. This is the total expected value, 16.8. This is the expected value. Now, having gotten the expected value, this is the total expected value. So you have to minus the return from the total expected value. And yes, return minus return bar. This is return bar. This symbol here is bar. It's called bar. So return bar. So and this is the return bar. So 27 minus 16.8, you have 10.2. 10.2. 18 minus 16.8. 18 minus 16.8. You have 1.2. 5 minus 16.8. You have minus 11.8. So the next thing is to square this. The square is return minus return bar squared. Just follow the step. When you follow the step, you get the standard deviation. This step I'm showing you. This is the process. This is the procedure. This is the precept you follow to get the standard deviation when you are given raw data like this of different return. This is security A. So we are trying to get the standard deviation. So now you have to square this. 10.2 that means my scientific calculator. 10.2 square 104 1.2 square 1.14 11 and 8 square. That's example 130. Note that this is having a negative sign, and when you square it, it will give you a positive. It will give you a positive figure. So that's that. So because of space, we'll come to this as a continuation. So having done that, you will multiply the probability with the what you got here. Thirty-one point 212. One 39 times 24. So when you sum this together, you have 31.212. You have 73. This is the variance. 73.56 is the variance. For you to get the standard deviation is the square root of variance. So 73.56 square root equals to 8.58. So this is the standard deviation. So once you follow this step, this is a continuation of from here. So when you follow this step, you're able to get the standard deviation. And the standard deviation is given in percentage. They are all in percentage. Since the question, the data are given, they are in percentage. So the level of deviation is 8.58%. So that's it for security A. We'll now go to security B. Security B. So you can pause the video and write if you want to write before we go for security B. So for security B, in order to do it in such a way that there will be space, I will have to wipe the board. So for security B, we'll go through the same route. Let me start from here. Okay, we already have the return. Okay, so from here we take expected value, expected value, expected value. So this times this, we have 10.5. This times this, we have 6. This times this, we have 6. Then we calculate the deviation from the expected value, which is arrow B. Return of B, security B, minus expected value of security B. Let's sum the expected value. This is 12, 22.5. Okay, so 35 minus 22.5. This is 12.5. 15 minus 22.5. Minus 7.5. 20 minus 22.5. Minus 2.5. So you square them. When you square them, $12.5, 156.25, 7.5 square root. 7.5 is 7.5 minus 7.5 times minus 7.5. In some textbook, they will skip this one. They'll just jump to this. It's still the same thing. I just want to show you bit by bit process. Bit by bit process, because I'm teaching. If it's in exam or if you already master it, you can skip this column. Just apply the probability here and square it. It will give you the same result. So 156.25 minus 30%, 46.875. Okay, so when you sum this together, I'll 17. Mhm. This is the variance. So now for you to get the standard deviation, you square this. You square it, you have 8.4%. So this is how you go about getting standard deviation from so the security. In explaining this that I've done, you discover that the security B has a standard deviation of 8.44, while security A has a standard deviation of 8.58. 8.58%, 8.44. Which one is less risky? Though depending on the return, you want to go for security A, you want to go for security B, and if you want to combine the both security in this portfolio, this is a portfolio. The portfolio has security A, investment A, investment B in a single portfolio. So you can combine both security A and security B together. Okay, so in a portfolio, there's what we call negatively correlated securities, negative correlation and positive correlation. Now, if the return, let me wipe this. You can write, pause the video and write. Now, in a portfolio, there's what is called correlation. Correlation. Okay, I got the spelling right. Correlation. Correlation can be positive, it can be negative. It can be neutral. Now, the movement of different investments in a portfolio is what we call correlation. Are they moving in the same direction? Are they moving in opposite direction? If you invest in, like what we have done, we invested in security A and security B. If the return for security A is positive and the return in security B is affected by the return of security A, making the return of security B positive as well at the same rate of security A, then we say that it is both securities are positively correlated. On the other hand, if the return of security B does not affect the return of security A, we can say it is negatively correlated. Now, if it's the return of security A is indifferent as far as security B is concerned, we say it's neutral correlation. But in a well-diversified portfolio, it is advisable to have different investments that are negatively correlated or fairly negatively correlated. Now, in practice, in a portfolio, if you have investments, different investments, it is not advisable to have investments in which the return of one security will affect the return of the other. If this security A is making profits at a certain pace or a certain rate, security B is also making profit at the same rate, it is not advisable. That's positive correlation. It's not advisable, because if one security crashes, it will affect the other security and the whole portfolio can crash. The idea of a portfolio is to enhance diversification. So in a well-balanced portfolio, one security should not affect the movement of the other. The securities should not go at the same rate of return, the same pace, the same rate of return. So it is advisable to hold, when you are holding a securities in the portfolio, you make them fairly, if at all, at least fairly negatively correlated. It's not that you should make loss in one and make profit in the other. No. The profit of one, the rate of return of one should not affect the rate of return of the other. It should not be at the same pace. You can be making profit of, say, security A, return of, not profit, let me use the word return on investment or return on, say, 10%. Security B should not be 10% when security A is 10%. Security B can be 20%, can be 30%. Okay, so this is so that when the risk for this one will be low. Let's say the risk is 5% because the return is 10%. The risk for this is, let's say, if the risk is 20, or let's say 15%. 15%. Because if it is the same level of risk, it's already a problem with the same level of return. So that when there's an issue with this, at least you still have security A still making return of 10%, probably annually, as the case may be. So this is advisable. This one is just neutral, like break even. So that's that for correlation. Now you may be asked from raw data, we are still dealing with raw data. You may be asked to find a correlation of a security. The formula for correlation, that word for correlation is relationship between securities in a portfolio. So we use security A and B as an illustration. So this is the symbol. This is how you write it. Correlation of security A and B. The relationship between security A and B. It will be probability. Summation of the probability what we got at that other side of A multiplied by I will explain. Let's hold it there. But in talking about correlation, there's also what we call covariance. Covariance. But before then, let me explain the formula. This is summation of the probability of this. We already got this in the previous calculation, and this. So you are weighting them together and dividing by the standard deviation of A times the standard deviation of B. So this is how to get correlation. You are finding the relationship between security A and B, the deviation of security A and security B. So covariance is from the word covariance, two or more, the variance of security A and B. And covariance is calculated as this. You will discover that this one is squared because likes have to come together. Difference, we have to bring this to the level of the covariance. So it's no longer just because for you to get your variance, you need to take standard deviation back to the variance. So in getting your variance, you have to square the standard deviation for you to get the variance. So this is how to get correlation, this is how to get covariance. So from raw data, so you can just take a minute and look at the formula very well. All right, so from what we did, we can get, let's try and calculate the correlation and the covariance. In case you are asked in the exam, in the situation of exam, what did we get from? We have to weight them. What we got in this times what we got in this, the standard deviation of A and the standard deviation of B. So in the calculation we had for security A, we had 10.2, we had 10.2, we had 1.2, we had 11.8. For B, we have 10.5, we have 7.5, we have 2.5. So when you sum this together, you have what? 10.2 plus 1.2 plus 11.8, 23.2, 22.5. I hope I'm right. 12.5 plus 7.5 plus 2.5. Okay. So all multiplied by the probability. So for this we have probability of 30, we have probability of 40, we have probability of 30. So you multiply across, so it will be 30% times 10.2, 30% times 10.2 times 12.5. Now 38.25 times 1.2 times 7.5, 3.6. Let me do it again. I hope I'm right. Okay, correct. So when you sum this together, you have 38.2 50.7. So, and what's the standard deviation for A and standard deviation for B? 8.58, 8.4. 8.58. So we have 50.7 over. So we have 0.7. So you can write. So, but we have 0.7 as the correlation. So you can also use the formula to check for covariance. Because of time, I'm not going to do that. So therefore, the relationship between security A and B is 0.7. So is this positive correlation, negative correlation, or what? Or no, it's neutral. If it is neutral, it will be 0. If it is negative correlation, it will be minus something. This is positive correlation. Positive correlation, 0.7. So if you look at what we got in standard deviation, we got 8.58, and the other is 8.4. It's almost even the same, almost the same. So it's positively correlated. It goes the same way. When that probability is 30, it goes in a particular direction. When it's 40, it goes in a particular direction. So they are positively correlated. Security A and security B are positively correlated, 0.7. All right. So that's that for when you are given a raw data. So when you are given a, let's check out for an icon question. Okay, I have here an account question, November 2019. November 2019. So you can study that for a while. In our next class, we will solve question 4. November 2019 question 4. We will solve that. But before we solve that, you will need to understand what we call in a portfolio, what we call the alpha value. Alpha value. What is alpha value? Alpha value is when we have securities that have abnormal returns. These are alpha values. Alpha values. So investments in investor or stockbrokers or advisor, analysts, financial analysts use this alpha value to advise their clients on which security to hold, which security to buy, which security to sell. So it's used to measure the abnormality in security. So it will tell you the security to hold, the security to buy, and the security to sell. The alpha value is depicted as this. This is the symbol for the alpha value. Alpha value. So when the alpha value, how do you know the security to hold? How do you know the security to buy? And how do you know the security to sell? If the alpha value is equals to 0, this security is properly priced. Therefore, you hold it. If the alpha value is 0, the security is properly priced, and therefore you hold it. If the alpha value is less than 0, if the alpha value is less than 0, it means that the security is overpriced, and therefore you sell. If the alpha value is greater than 0, this is underpriced, and therefore you buy. We are going to be illustrating with figures on what it is for an alpha value to become properly priced, to become overpriced, and to become underpriced. So if it is 0, it's properly priced, and therefore the investor should hold that security. If the alpha value is less than 0, it's overpriced, and the investor should sell the security. If the alpha value is greater than 0, it's underpriced, and the investor should buy the security. So the alpha value measures the unexpected return on a security. That is the alpha value. So in our next lecture, we are going to be solving questions, account questions, other questions, as far as portfolio theory is concerned. So this is just an introduction of portfolio theory. In our next video, we are going to go deeper and solve questions on how it can apply to investments, to securities. in a portfolio. Thank you very much. Have a lovely weekend. Bye.